Imagine a world where the tiniest particles dance to a cosmic melody, their movements orchestrated by vibrating strings of energy. This is the captivating realm of string theory, a mind-bending framework that attempts to explain the fundamental building blocks of our universe. String theory proposes that everything around us, from the smallest atom to the largest galaxy, is made up of these minuscule, vibrating strings. Just like a violin string vibrating at different frequencies produces different musical notes, these strings vibrate in different ways to create the particles we observe. These strings are incredibly small, far smaller than anything we can currently observe with even our most powerful microscopes. To give you an idea of their size, if an atom were enlarged to the size of our solar system, a string would be about as big as a tree. Despite their infinitesimal size, strings hold the potential to unlock some of the universe's biggest secrets. By understanding how they vibrate and interact, string theorists hope to develop a theory of everything that can explain all the forces of nature and the behavior of matter and energy. One of the most exciting aspects of string theory is its potential to unify the four fundamental forces of nature: gravity, electromagnetism, the weak nuclear force, and the strong nuclear force. This unification has been a long-standing goal in the field of physics, as it promises to provide a more comprehensive understanding of the universe. The idea is that these forces, which seem distinct in our everyday experiences, might actually be different expressions of a single underlying principle. Currently, physics describes these forces using two different frameworks: general relativity for gravity, and the standard model for the other three forces. General relativity, developed by Albert Einstein, explains how gravity works on a large scale, such as the motion of planets and the bending of light around stars. On the other hand, the standard model describes the other three forces at the subatomic level, governing the behavior of particles like electrons and quarks. However, these two theories are incompatible at extremely high energies, such as those found in the early universe or black holes. In these extreme conditions, the equations of general relativity break down, and the standard model fails to provide a complete picture. This incompatibility has been a major challenge for physicists, who have long sought a theory that can seamlessly integrate both frameworks. String theory offers a way to bridge this gap. It proposes that the fundamental building blocks of the universe are not point-like particles, but tiny, vibrating strings. These strings can vibrate at different frequencies, and the different modes of vibration correspond to different particles and forces. It suggests that all four forces are simply different manifestations of the same underlying force, arising from the different ways strings can vibrate. This elegant idea has the potential to unify our understanding of the fundamental forces, providing a single framework that can describe all of nature's interactions. Imagine a guitar string that can produce different notes depending on how it's plucked. Similarly, strings vibrating in different modes could give rise to the different forces we observe. Just as a musician can create a symphony from a single instrument, string theory aims to create a unified symphony of the fundamental forces, offering a harmonious understanding of the universe. Section 4. Exploring hidden dimensions. To accommodate all the different vibrations needed to explain the particles and forces we see, string theory requires the existence of extraspatial dimensions beyond the familiar three dimensions of space: length, width, height, and one dimension of time that we experience in our everyday lives. These dimensions are the fabric of our reality, the stage upon which all physical phenomena play out. These extra dimensions are thought to be curled up or compactified at incredibly small scales, far too small for us to detect directly. Imagine trying to see the intricate details of a tiny object with the naked eye. It's simply beyond our current capabilities. Think of a garden hose. From a distance, it looks like a one-dimensional line, a simple, unassuming object, but up close you can see that it has a second curled-up dimension. This hidden dimension is not apparent until you examine it closely. Similarly, our universe might have hidden dimensions that are too small for us to perceive. These dimensions could hold the key to understanding the fundamental nature of reality, potentially unlocking new realms of physics and expanding our comprehension of the cosmos. Section 5. The Symphony of Reality. String theory is still a work in progress, and many of its predictions remain to be experimentally verified. This theory suggests that the fundamental particles we observe are not point-like dots but rather tiny, vibrating strings. These strings can vibrate at different frequencies, and each frequency corresponds to a different particle. It's a radical departure from the traditional view of particle physics. However, its elegance and potential to unravel some of the universe's deepest mysteries have captivated the imaginations of physicists and laypeople alike. The idea that everything in the universe, from the smallest quark to the largest galaxy, could be connected by these tiny strings is both mind-boggling and beautiful. If string theory proves correct, it would mean that our universe is a far stranger and more wonderful place than we ever imagined. A grand cosmic symphony played out on vibrating strings of energy. Imagine a universe where every particle, every force, and every interaction is a note in a grand cosmic melody. P.S. Tired of scrolling? Subscribe to my channel and dive deeper into the mind-blowing world of theoretical physics. By subscribing, you'll get access to exclusive content, in-depth analyses, and the latest updates in the world of science. It's like Netflix, but for nerds. Imagine having a library of fascinating science content at your fingertips, ready to be explored whenever you want, and you know you're secretly a nerd at heart. Embrace your curiosity and join a community of like-minded individuals who share your passion for understanding the universe.